Hello, my name is Sharon Pruitt. Today I am conducting a repeated measures ANOVA to determine whether chocolate has a significant effect on attitude over time. The research question is, does attitude significantly change across 4 time points? Pre-test, 5 minutes after eating chocolate, 1 hour later, and 4 hours later. Because the same participants were measured 4 times, a repeated measures design is appropriate. The null hypothesis states that there is no significant difference in mean attitude scores across the 4 time points. The alternative hypothesis states that at least one time point differs significantly from the others. At this time, I will set up my data analysis. One goes to Analyze, General Linear Model, and click on Repeated Measures. Here I define time as the within subjects factor with 4 levels. Each participant has 4 scores. So I go to define and I move attitude underscore 0 first, attitude underscore 1, and continue to move the different attitude within their respective time slots. Next, I click on EM means, and I want to compare main effects. I'll move time first over into the display means box. Click on compare main effects. Click continue. And I'll also click options to get the descriptive statistics as well as the estimates of effect size. Click continue, and then OK. And I get my data output. Because the same participants are measured repeatedly, this violates independence across time points, which is why we must check the assumption of sphericity. One critical assumption in repeated measures ANOVA is sphericity. Sphericity means that the variance of the differences between all combinations of time points are equal. In simple terms, the spread of score differences between pretest and 5 minutes should be similar to the spread between pretest and 1 hour, and so on. To test this assumption, we examine Mauchly's test of sphericity. In order to interpret the results, Mauchly's W is 0.860 and the p-value is 0.683. Because the p-value is greater than 0.05, the test is not statistically significant. This means we fail to reject the null hypothesis of sphericity. Therefore, the assumption of sphericity is met. This is important because when sphericity is met, we use the sphericity assumed row in the test of within subjects effects table. If the test had been significant, meaning P was less than 0.05, we would instead interpret the greenhouse geyser or the Hunks-Felts corrected results. Now I interpret the sphericity assumed row. The repeated measures ANOVA shows a statistically significant effect of time on attitude. F with 3 and 66 degrees of freedom equals 5.681. P is equal to 0.002. And because P is less than 0.05, I reject the null hypothesis. This means that attitude significantly changed across at least one of the 4 time points. Next, I examine effect size using partial eta-squared. The partial eta-squared value is 0.205. Using conventional benchmarks, 0.01 is small, 0.06 equal medium, and 0.14 is equal large. So a value of 0.205 indicates a large effect size. This means time explains approximately 20.5% of the variance in attitude scores. This is not only statistically significant, it is substantively meaningful. We can examine the means from the point to estimated marginal means. We see that during the pretest, the mean was 76.57. 5 minutes after eating the chocolate, the mean increased to 83.87. 1 hour later, the mean was 79.087.09. And 4 hours later, the mean was 78.44. We see that attitude increases sharply 5 minutes after chocolate consumption, then declines somewhat at 1 hour and 4 hours, though still remains slightly above the baseline. Now I examine which specific time points differ significantly by looking at pairwise comparisons. Time 1 and 2 versus 2 gives us a p-value of less than 0.001. That is statistically significant. Then we look at time 2 versus 3. We also have a p-value less than 0.05, 0.010. And then time 2 versus time 4, a p-value of 0.005. The significant differences involve the 5-minute condition compared to the other time points, which have p-values greater than 0.05. The significant differences showed up between the 5-minute interval and the pretest. This suggests then that chocolate has an immediate positive effect on attitude, but the effect diminishes over time. While the results are statistically significant, it is also important to consider practical meaning. The increase from 76.57 to 83.87 represents a noticeable shift in attitude. However, the effect appears temporary as the scores decrease over the next few hours. This suggests that chocolate may provide a short-term mood enhancement rather than a sustained improvement in attitude. In real-world terms, chocolate may boost immediate mood, but it does not produce long-term attitude change. In summary, a repeated measures ANOVA revealed a significant effect of time on attitude with an F value with 3 and 66 degrees of freedom equaling 5.681 and a p-value of 0.002. Mauchly's and test of sphericity was not significant. P was equal to 0.683, indicating that the assumption of sphericity was met. Pairwise comparisons reveal that attitude significantly increased 5 minutes after chocolate consumption, but declined at later time points. As stated before, in conclusion, the repeated measures of ANOVA showed that chocolate had a statistically significant effect on attitude over time. The assumption of sphericity was met according to Mauchly's test, allowing interpretation of the standard within subjects' results. Attitude increased notably 5 minutes after chocolate consumption, but gradually declined over the next several hours. Although the effect size was large, the pattern suggests that chocolate produces a short-term improvement in attitude rather than a sustained long-term effect or long-term change. This concludes my video.